last video, we have discussed how to convert epsilon NFA to NFA, and we have used delta dash transition function for that. In this video, we will convert epsilon NFA to NFA using same function, but the function representation is a bit different. Here we will be using the tabular format. Whichever way you find appropriate, you can use it. In both the cases, output will not change. This is our problem NFA. This we have to convert it into NFA. So as a first step, we need to find out epsilon closure of all the states. There are two rules. Every state is epsilon closure of itself, and we have to add all those states into epsilon closure if they are reachable from the current state just by consuming epsilon. So based on these two facts, we can say that epsilon closure of A is A, B and D. The state itself will be by default in epsilon closure, and by consuming epsilon from state A we can go to B, and from B we can go to D. So those two we have to add into epsilon closure of A. Similarly, epsilon closure of B would be B and D states, epsilon closure of C would be C, and epsilon closure of D would be D only. Now we have to evaluate the delta dash transition function for all the states. So delta dash transition function for state Qi for alphabet AK is given by epsilon closure of delta of epsilon closure Qi comma AK. So for every pair of Qi comma AK, we have to find out delta function, and then we have to take the epsilon closure of that. In previous video, we have done it step by step without table. Now we will directly draw the table. So we do not need to write down all the steps for this. So this method might be faster compared to the last we discussed in last video. Epsilon closure of delta, epsilon closure A comma 0. So this procedure we can do in 3 steps. First, we need to calculate epsilon closure of state itself. Then we have to find out delta function or delta transition for input alphabet, and whatever output we have, again we have to find epsilon closure of that. So epsilon closure of A is ABD. Now we will find the delta function for input 0. So if we look at the transition diagram, then from A, if we read 0, we are remaining on A. From B, if we read 0, we are moving to C. And from D, if we read 0, we are remaining on D. So we have computed the inner part, that is delta epsilon closure of A on 0. And now we have to take epsilon closure of A, C and D. So epsilon closure of A is already computed, which is ABD. Epsilon closure of C is just a C, and that of D is D. And we just have to take the union of that. So that will give us the final delta dash transition function. So on input 0, delta dash transition function for A would be A, B, C, D. Same process we have to repeat for input 1 now. So that function we will call it as a epsilon closure of delta epsilon closure of A on input 1. So epsilon closure of A, first we will compute, that is ABD. Now we will compute delta transition function from A, B and D for input 1. So there is no transition from input A, from state A for input 1. So that is phi. Same is for B. And on D, if we read 1, we are remaining on same state D. So inner part is computed. Now we just have to take the epsilon closure of all these 3 states. So epsilon closure of phi would be phi, and epsilon closure of D is D. And union of this would give us the delta dash transition function for A comma 1. So that is just D. Same process we have to repeat for state B, C and D. So epsilon closure of B first will compute, which is B and D states. Then we have to take delta transition function on 0. So from B, if we read 0, we are moving to C. From D, if we read 0, we are remaining on D. And now we have to take epsilon closure of that. So epsilon closure of C is C, and epsilon closure of D is D. So finally, the transition delta dash transition function of B on 0 would be C comma D only. Now we will repeat the process for input alphabet 1. So epsilon closure of B, that is already known, and transition for 1 would be phi and D, because there is no transition from B on input 1. and D will remain on D on reading 1, and epsilon closure of that would be D. So that entry we have to make into the transition table. Process we have to repeat for state C now. Epsilon closure of C is C, and on input 0 it is not going anywhere, so it's phi, and epsilon closure of phi is phi itself. So there will not be any entry for that. So C0 would be null, or we can say phi. Repeat it for input 1. So epsilon closure of C is C. On input 1 it is going to be, as we can see from transition diagram, from state C if we read 1 it is going to state B. And now we have to take epsilon closure of that, which is B comma D. So that entry we have to make into a transition table. Next we have to repeat the same procedure for state D. Epsilon closure of D is D. The transition on 0 is D, and epsilon closure of that is as well D. So let's add that entry into transition table. Repeat it for input alphabet 1. So epsilon closure of D is D, and on 1 it is moving to D only, and the epsilon closure of that is just D. So that entry we have to add. So all 4 states are processed. We have already computed delta dash transition function for all 4 states. We got this transition table, and this transition table is for the NFA. Now we just have to draw corresponding transition diagram for that, and you can see there is no epsilon transition into this, as well as this is an NFA. So this NFA is equivalent to the original epsilon NFA. Thank you. That's it for today, folks. See you in next video. If you think this video was useful to you, then please like, comment and share. Don't forget to subscribe the channel CodeCrucks. Press the bell icon for the notification of latest videos. Stay connected, stay tuned. Thanks for watching. Bye-bye.